Kia ora Year 13. This is a quick video to show you how we can use the factor theorem to solve problems. It's based on New Delta, chapter 1203. I'm doing one example out of the book and one that I've made up. So suppose that we were starting with the following polynomial in x cubed minus 4x squared plus x plus 6. And we're asked to factorise that fully. So step 1 is to use the factor theorem, which I'm just going to call FT, to figure out the first factor. And then that kind of gives us a clue. Then we've got two options for the second step. We can either use your favourite new thing, which is long division, or we can do something which I call matching up the coefficients. So match the coefficients. So we're going to look at this method on the next slide. Okay, so let's start with writing out the polynomial. Now, what we need to do is to find a first factor. So this is basically guess and check. I always start by trying 1, because that's the easiest. So what we're saying here is, we're asking, is x minus 1 a factor? The factor theorem tells me that if x minus a is a factor, then when I substitute in a into my polynomial, the result should be 0. And that's all I need to do to show that something's a factor. So p of 1 is going to equal 1 minus 4 plus 1 plus 6. So we look at that. Unfortunately, that doesn't work because that equals 4, which is not equal to 0. And that means I can say that x minus 1 is not a factor. So let's now try negative 1. What do we get when we do that? Well, we get negative 1 minus 4 minus 1 plus 6. Just remember to be really careful with your powers when you've got odd numbers. Okay, now that does give me 0. So that makes me happy. That means that I've found my first factor. So we need to explain that by the factor theorem, this tells me that x plus 1 is a factor. And that's the big clue that we need to proceed. Right, so what we've got now is we've got our polynomial in expanded form, which looks like this. I'm going to go straight to the matching coefficients method because I think most of you are going to like it more than long division. So here's what we do. We say, well, we know that x plus 1 is a factor. So now I'm going to have 3 bits in here. Something with x squared, something with the x's, and something with the constant. What we're trying to say is, how will I get a plus 6 here if I know that this first factor is plus 1? So this is the easiest one to start with, or this one. 1 times what will give me 6? Well, I'm going to put in a plus 6 here. I know that that's got to be the case. Right, now let's take a look at how I'm going to match up to get an x cubed when I expand. Well, it must be x times x squared. Right, so far so good. Now I can pick on either this one or this one to match next. Whichever one I don't choose, I'm going to use to check. So expanding this out in my head, or underneath, I'm now going to get x cubed, and I'm getting plus x squared here. Now the only way I'm going to get the other x squared term is going to come from this part of the expansion. The x here times whatever's in here, which is the x. I want to end up with negative 4x squared, and I've already got a plus x squared coming in. So what do I need to have in here? Well, it must be minus 5x squared. So in here, I'm going to try putting minus 5x. Now you'll find once you start practicing these, you won't need to do a whole lot of written working, but you probably will when you get started. So what we're going to do now is we're going to check, do I end up getting a plus x with that pattern? So let's just expand what we've got to make sure we get x cubed minus 5x squared plus 6x plus x squared minus 5x plus 6. So putting that all together, I get x cubed minus 4x squared. Well, we knew that already. And happily, I get plus 6x minus 5x, so plus x plus 6. Okay, so that's probably my preferred method for how to fully factorise something using the factor theorem. What we've then got to look at is whether this will factorise nicely. Now in exercise 1203, they all do, but in real life it might not be that simple. But in this case, I'm just going to erase some of this so I have a little bit more space. Let's get rid of this, and I'll get rid of this. So let's see what we can do with this. Well, it's a year 10 problem now. I've just got x plus 1 times x minus 2 and x minus 3. Now, just for those of you who do really like long division, I'm going to do it that way on the next slide. Okay, so we've got to the point where we've figured out that x plus 1 is a factor. And here's my polynomial. So I've got x cubed minus 4x squared plus x plus 6. So off we go as usual. X times what will match up to this? It'll be x squared. So I get x cubed plus x squared. So I'm multiplying this by this factor. I'm going to subtract that and see what's left over. So here I'll have negative 4 minus x squared minus 5x squared. Bring down the x plus x, and let's do it again. So x times what will give me this? It'll be minus 5x, negative 5x squared minus 5x. Alright, again, that's the product of my factor and my new term. And I'm subtracting that to see what I've got left over. That gives me 6x plus 6. Right, so we've done that. So we get to the same point. Now, I had students last year who really liked doing long division once they'd done enough examples, but overall I'd say most year 12s and 13s preferred to do the matching coefficients method. So try both of them and see if you can get comfortable with the two different ones. I'm going to do another one, but I'm going to do it in a separate video so that this isn't too long. Thanks for watching.